Alright guys, for the very last part of these notes, we're going to finish with mechanical energy and then a little drawing to explain it all. So with mechanical energy, it is total energy. Okay, total energy, or the amount of work in total. So what I mean by total is that you would literally add up the potential and the kinetic. So our formula on this one is very easy. Mechanical energy is the GPE, or just PE, so I'm going to put the G as optional, plus the kinetic energy. So that is our formula for mechanical energy. So we would add them. Now, another way you could write that out would be like a bigger version. So you would do your M times G times H, which is our potential energy formula, plus our kinetic energy formula, which is 1/2 times M times V squared. Okay, and you would just add those together. We are going to give an example of it switching back and forth between potential and kinetic. So let's say that I have a cliff. Again, I'm really all about cliff diving. But if I have a person, okay, who is going to jump off the cliff, it's very, very safe. No one is going to die. In fact, cliff diving is actually very dangerous. But in my example, you have to keep in mind that no one's going to get hurt, and we're just using it for the fun of a science example. So let's say that we have the GPE is what we're going to write on this side, okay? Then our kinetic, and then our mechanical, okay? And remember that for energy, we always use joules, okay? We always use joules, okay? Hold on 1 second. Okay, sorry. So here we go. So we're gonna have, position A, position B, C, and D, okay? Now, I'm gonna space them out for note purposes, but obviously we know that as it falls down, that gap should be getting bigger and bigger and bigger. So let's say that at the very, very top, okay, it is going to be 100 joules of potential energy. We know the potential energy should be high because it's high off the ground, okay? And our kinetic energy at this moment, let's say it was even, okay? Our potential energy, let's say, or kinetic is 5 joules, okay? They're starting to move, but just slightly. So 5 joules would be 100 plus 5 is 105 joules total. Okay, let's say for a little bit further down, okay, let's say that it's at 80 joules here, okay. Why would it be going down? That's because it's closer to the ground, it's losing GP, but the kinetic energy is going to be increasing, okay. It's going to be increasing because he's moving faster, okay. So what that means is that my kinetic energy would be at 25 joules. How do I know that? Because my mechanical should stay the same always. It's our total energy. So I can actually go ahead and fill that in right now. So it's 105 all the way down. Okay. Let's say down here he is at 45 joules. Okay. So you would do the 105 minus the 45, and you would know that that would be 60 joules. Okay, so he's picking up kinetic because he's going faster, but he's lowering his GPE because he's closer to the ground. And then let's say that here it is 12 joules. We would do the 105 minus the 12, and we would get that it's 93 joules of kinetic. Okay, so this is just a little bit of an example. Okay, so we're going to kind of dissect this information a little bit. So there's this law where we're not losing energy, it's just changing from one form to another. So as he's falling, he's losing his GPE, but it's not lost, it's just getting transferred into a different type of energy, which is kinetic. So I would hope you guys know that that law has a name, okay? So that is the law of conservation of energy. Okay, the law of conservation of energy. Okay, so I'm going to go ahead and write kind of three main ideas of what is happening. So in the first column, when we're talking about GPE, okay, our GPE is decreasing. Okay, so it decreases. Okay, because he's not as high off the ground. Okay, as he's falling, his GPE is going down. Now his kinetic energy, on the other hand, is increasing. Okay, so it increases because he's picking up speed. So the energy is going from GPE and converting into kinetic. Now, the mechanical energy stays the same. Okay, it stays the same because energy is not lost in a system. Okay, and that is because of the law of conservation of energy. Now, sometimes if the object is touching something, okay, a very, very small amount, could be lost as a result of friction. So it's sometimes lost as heat. So for example, like a roller coaster, the metal tracks would then be losing a little bit of energy, but such a small fraction in comparison to the whole entire system. So these are our energy notes. If you guys have questions, please shoot me an email or a remind message. I hope this made it a little bit more understandable. Hope you guys are doing well. Make sure you guys are writing these in your Jones notes, and make sure that you guys are following all the directions on my team's assignments. Hope you guys are doing well. Hang in there. I will see you guys soon.